All right, we are doing 5-1, and we're going to start talking about how to find the area of a triangle. So just similar to when we were doing law of cosines, it's going to depend on what information is given to us, which formulas we're going to use. Okay, so we have to pay attention to what we have, what we know, and then figure out from there what we need to use. Normally in math before trig, you would need to know the height of your triangle, and the area would be 1/2 base times height. Okay, that's normal triangle. Now we're going to talk about triangles within our unit circle with those rectangular coordinates that we found last section. So it's still going to be 1/2 base times height, but the base and the height are going to be worded a little bit differently, and it's obviously going to use some trig functions. Right now, the three things that we need are two sides and the included angle. Okay, which we also needed for the law of cosines, so we know what that looks like. So it's going to be two little letters and a non-matching big letter, so like A, B, and then we would need angle C. Okay, or if we have little c, little b, then we would need angle A. Okay, so you need two little letters and a non-matching big letter. The formula itself is not complicated. Just to kind of give you an idea of what we're working with, this is what it looks like. So here's our triangle. Our point up at the top is A cosine B, A sine B. Those are our rectangular coordinates that we found last section. The height of the triangle is going to be the y value of that point. Okay, it's the sine of the angle. It's little a times the sine of your angle B, because sine is y, which is height. So this height of your triangle is a times the sine of B, which is written right here. Okay, and then you just need to know, so you need to know little a, and we need to know the base in this case, which would be little c. Okay, so that's where it's coming from, is the rectangular coordinates, and the y value of that rectangular coordinate is a times sine b. So here are our three versions of the same formula. You need two side lengths and the included angle, and the area is always half of the two sides because it's 1/2 base times height, so half of the two sides and the sine of their included angle. Okay, so it's pretty straightforward. You need two little letters and a non-matching big letter, and it's just half times both of the side lengths times the sine of the angle, and it's sine because it's height, which is y, which is your up and down value. So it says find the area if little a is 12, little b is 8, and the measure of angle C is 30. So you know you have the right information because none of these letters match, and you have two small letters and one big letter. So the area, since we have angle C, is going to be 1/2 A, B, sine C. Okay? So 1/2. Our A length was 12. Our B length was 8. And it's times the sine of our included angle, which is 30. You should be able to put that in your calculator all at one time. 1/2 times 12 times 8 times the sine of 30. That straight up gives you your area. You do not have to take the square root or second sine or anything of that nature. We're just finding the area, which is what that's going to give you. So you just put that in your calculator and you should get 24. If you do not get a whole number, we're going to round to the nearest tenth on these. So 1 decimal place, but that one came out evenly. And that's it. Okay, this one says of an equilateral triangle with the sides of 10 units. So if you're using your formula, we'll say A and B. So A and B are both 10 because it's equilateral, okay? So they didn't tell us exactly the letters we're going to use, but we can just make it up ourselves because they're all the same. So A and B are 10. We need an angle. We need angle C. So we need the measure of angle C. Equilateral triangles have all side lengths the same, which means their angles are all the same. So all of the interior angles of a triangle add up to 180. If we divide that by 3 to figure out what one of them is, we get that one angle is 60 degrees. Okay? Once you know that, you just plug it all in. So area is 1/2, don't lose your half, times both of the side lengths that you know, which are both 10, times the sine of the included angle, which is automatically 60 degrees because it's equilateral. And you just put that in your calculator. You do not have to do anything once you get the answer except round it to the nearest tenth, which gives you 43.3. Okay. Parallelogram has two congruent triangles. Okay, let's see if we can make one. A parallelogram has two congruent triangles. So you can find the area, oh that was bad, of one of them by using your formula. Okay, that's what this is. This would be one of those triangles. And then you could just multiply it by 2. Okay? However, if you're thinking about it, if we multiply by 1/2 to find the area of the triangle, and then multiply it by 2 to double it for both, I can just not multiply by the 1/2 because that would find the area of the entire parallelogram. Okay? So the area of a triangle is 1/2 base times height. But if I'm going to double it to make the parallelogram, then just don't multiply it by the 1/2 to begin with. So the fact that this is a parallelogram means that I can get rid of the 1/2. Okay, so the area is just your side length, so 14 times 10 times the sine of the included angle, which is 36. No 1/2 needed because it's a parallelogram, so you would double it anyway. So just leave it out and round to the nearest tenth, so 82.3. Okay? And that's it. So parallelogram, you don't have to have a 1/2. All right, the last thing is that if they give you the area and ask you to find the angle, okay, you fill in everything you know into their formula as normal. But if you then solve for the sine of your angle, okay, if you solve for the sine of the angle, you need to second sine your answer. Okay, so that's what the sine inverse means. You have to use your sine to the -1 or second sine in order to find your angle. We're not going to worry about minutes right now. We're just going to do whole number for the angle right now. So it says in triangle ABC, little a is 12, little b is 20, and the area is 80. Find the measure of angle C. So they need to know the measure of the included angle. Okay, I guess we can do minutes. Okay, so area equals 1/2, because we're back to triangles, A, B, sine C. Okay, and we plug in what we know. We know that the area is 80, so this time you know the answer. So 80 equals 1/2. Little a is 12, side b is 20, and we do not know angle C, so just times the sine of C. Okay? Since you've got things on both sides of your equal sign, you can't just put it all in your calculator at once. You can put this into your calculator. So 80 equals 1/2 times 12 times 20 is 120 times the sine of angle C. Now sine, you're trying to get sine C by itself. Right now sine C is being multiplied by 120, so you are going to divide both sides by 120, which cancels on the right. Okay, so you get that sine C. So if you do 80 divided by 120, you're going to get a decimal of some sort. Okay, so it's going to looks like 0.6 repeating. So 0.66 repeating. Okay, that's the sine of your angle. You want the angle, so then you second sine your answer. So leave the 0.6 repeating in your calculator. Don't round it, don't do anything. Then second sine, because that's the sine of your angle, second answer. We get 41.81. Okay. It said to the round to the nearest minute, so we're going to take the decimal and multiply it by 60 because minutes are split into 60ths. So I do 0.81 times 60, and we get a 48.6. Okay, so angle C, these are your degrees, so 41 minutes, and we're going to say 41 degrees. Whole number are your degrees, so 41 degrees, and we're going to say 49 minutes, because 48.6 rounds to 49. Okay? So to do minutes, you just take your decimal and multiply by 60. Your whole number is your degree, and then the decimal that you multiplied ends up being your minutes. Okay, so you have to second sign your answer when you're doing that. Okay, that's it. Do your 5-1.